2. All the hydrogens are great. Now nitrogen needs 8 electrons. Does he have 8? So what's going to happen is those 2 electrons there, that oxygen will have to drop them in for a double bond. This is something I'm just going to warn you right here. This takes a lot of practice. It's a lot of trial and error. So don't get frustrated when we begin this. These are the steps in drawing a Lewis structure, and I'm just going to demonstrate the steps by doing an example. So let's draw a Lewis structure for this molecule, and this is ammonia. It's 1 nitrogen with 3 hydrogens bonded to it. The first step is to get the total number of valence electrons. So you're going to need to locate these elements on the periodic table and use what you know about valence electrons. And I like to add them up like this. Nitrogen has 5, each hydrogen has 1, and there's 3 hydrogens. So I have a total of 8 valence electrons. And I write this every time I do this. If you will write down the total number of valence electrons, it will save you at the end. Then determine the central atom. Well, I'm guessing here that it's probably nitrogen. And then since there's 3 hydrogens, we'll place those around. Okay, remember I said this is trial and error. Then we've got 8 valence electrons to position around each atom until everybody has 8, except for hydrogen, and he only needs 2. So we're going to use dots here. I need 2 dots. That would be 2 electrons to bond these together. And then I've got 2 extra electrons. I have 8 electrons to position wherever needed so that everybody has satisfied the octet rule. So have I done that? Does hydrogen have enough electrons? Well, how many does he need? 8? No, only 2. He's got 2. He thinks those are his. 2, 2. All the hydrogens are great. Now nitrogen needs 8 electrons. Does he have 8? He does, because everybody's sharing. So it looks like octet rule is satisfied. Now we don't need to leave the dots like this. We're going to substitute a dash for those covalent bonds. Okay, and don't forget those 2 unpaired electrons that are on the nitrogen, they're still there. So this is a proper Lewis structure. Now, what is the covalent bond? Guess what it is? That stick is a covalent bond, and that represents 2 shared electrons. Now up here, what do we have? Those 2 that are 2 dots, those are unshared or non-shared. We call those lone pairs, like L-O-N-E, lone pair. Now we may need to use double and triple bonds, but I'll show you that later in the video. Let's do a couple more examples. So first step is always total valence electrons. Each hydrogen has 1, so I have 2 valence electrons. And let's see what we have. Well, it's not going to be too hard. Each hydrogen only needs 2, and they were going to share the 2. That's it. Hydrogen, simple. Hydrogen, there's 1 valence electron. Bromine is a halogen, has 7, so I have 8 valence. So I'm going to draw my H beside the Br and have 8 electrons to deal with. Well, let's start by gluing them together with a covalent bond. That's 2 electrons. Now I've got 6 to go. Where do they go? Does the hydrogen need any more? It doesn't, because it only needs a total of 2, and it's already satisfied. So the other 6 electrons, 2, 4, 6, go there. So hydrogen's got his 2, and then bromine has his 8. So let's see, that guy has 2, and that guy has a total of 8. Now let's do a water molecule. I've got oxygen, hydrogen, and hydrogen. And let's do valence electrons. Each hydrogen brings 1, each oxygen brings 6. So look at that, I've got 8 electrons. So I'll put 2, 4. I've got 4 more to go. Where should they go? I better put them on oxygen, because hydrogen's already all full. So everybody's got 8 valence electrons. Now, when might we need double and triple bonds? When you get short on electrons, you might need to double and triple bond. So let me show you two examples. So oxygen, I've got 2 oxygen atoms. Each one brings 6. So I have 12 valence electrons. All right, I'll draw my 2 oxygen atoms. Now I've got 12 electrons to deal with. So I'm just going to start, hey, it's trial and error. I'm just going to start dropping them in. I've got to stick them together with 2. So there's 2, 4, 6, 8, 10, 12. Now, is everybody good? Does everybody have 8? The oxygen on the left, he has 8, but the one on the right only has 6. So this is not stable. So what's going to happen is those 2 electrons there, that oxygen will have to drop them in for a double bond. Now look, it doesn't matter what atom brought what electrons. It doesn't matter. We're just going to share them until everybody has 8. So this guy on the left has 2, 4, 6, 8. And the guy on the right has 8 as well. So oxygen is double bonded. Now let's do nitrogen. Each nitrogen only has 5 electrons, and I've got 2 nitrogens. So now I've got 10 electrons. So let's draw our 2 nitrogen atoms. And I can tell right now that I'm going to need to triple bond this. 2, 4, 6, 8, 10. So here's the deal. You've got to slide those electrons around so that everybody has 8. Okay, you can't just sort of add electrons. Like 12 or 10 electrons is all we have to deal with here. And so let's check. There's 6 shared plus 2 more, so that's 8. 6 plus 2 is 8. So those are examples of double and triple bonds. So you're going to single bond in unless you're very short on electrons, and then you might need to double bond. Remember, trial and error, it takes a lot of practice. You have to draw many Lewis structures before you are confident doing this. So hang in there and keep practicing.